Okay, you lucky 8th graders, we are now on problem 2.2. This is the next page in your packet. And your page looks like this. Yes. So it says find the side lengths of the squares. We actually did this yesterday. So a square with an area of 1 is made from a 1 by 1. A square with an area of 9 is made from having a 3 by 3. And a square with an area of 16 is made from having a 4 by 4. And then the square root of 1 equals 1, the square root of 9 equals 3, and the square root of 16 equals 4. And the square root of 25 equals 5. I totally didn't see that, so let's go ahead and draw a 25. This is obviously not to scale, and that would be a 5 by 5. And that is the square root of 25. If you can take a square root and you get a whole number, you should always do that. So the next question says, what is the area of a square with a side length of 12? So if a square, that means all the sides are the same, is a 12 by 12, the area would be 12 times 12, which is 144 units squared. And then it says 2.5. So 2.5 times 2.5 is 6.25 units squared. Because if you have 25 quarters, you have $6.25. And then it says the square root of what? So that would be a 144, because we know 12 times 12 gives you 144. And then this question is what times what gives you 2.5, so that would be 6.25. So these answers are coming from what we just did seconds ago. Okay, so again yesterday I had you draw that tilted square. I'll just draw this. This is totally not to scale. And this question is saying to take a centimeter ruler and actually line the ruler up and measure it right here. You should get something super close to 1.4-ish. So 1.4 is between 1 and 2. It is not equal to 2. Instead, it is the square root of 2. And if you use a calculator, the square root of 2, it's actually really large, I'm going to grab a calculator, is 1.414213562. It fills up the calculator. A good rounding number is 3 decimals, so 1.414 is great for the square root of 2. Hopefully your ruler was close, but it's not going to be exact, because who can do a ruler to that measurement? Not I. So now we're going to think about our squares. So 1 squared is 1. I'm going to do this actually differently. The square root of 1 is 1. So 2 squared is 4. You know what? I'm going to actually write this over here so it's longer. So 1 squared is 1, so the square root of 1 is 1. 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, so the square root of 9 is 3. 4 squared is 16, so the square root of 16 is 4. 5 squared is 25, so the square root of 25 is 5. 6 squared is 36, so the square root of 36 is 6. 7 squared is 49, so the square root of 49 is 7. 8 squared is 64, so the square root of 64 is 8. 9 squared is 81, so the square root of 81 is 9. 10 squared is 100, so the square root of 100 is 10. 11 squared is 121, so the square root of 121 is 11. 12 squared is 144, so the square root of 144 is 12. 13 squared is 169, so the square root of 169 is 13. So letter D says, between which two whole numbers is the square root of 5? So the square root of 5 is right here. It's between 2 and 3. And it's closer to 2. because it's closer to 4 than 9. Oh, which is what I just did right there. So then it says to use the square root key on your calculator and take the square root of 5, and you get 2.236. I'm just going to keep going 3 decimals, rounding it. So 2.236. So it is definitely closer to 2.2, than 3. And then it says to measure it. Did I skip something here? Oh. So measure it. Or first you can approximate, and then this is with the calculator. So your approximation can be whatever. This is the calculator. Letter E we've actually already done. So we're going to go back and put all of those as a decimal. So if you remember, we had this diagonal length, and it was square root of 2, so that's 1.414. That was our 1 by 1. And then we had a 1 by 2, and that was the square root of 5. And the square root of 5 we just found on the calculator as 2.236. And then we had a 1 by 3, and that was the square root of 10. And if you put in your calculator the square root of 10, you get 3.162. And we also had a 2 by 3. I'll draw that right here. 2 by 3, 2 spaces by 3 spaces. And that was the square root. Actually, we had a 2 by 2, not a 2 by 3. Sorry. So we also had a 2 by 2. So 2 spaces by 2 spaces. And that was the square root of 8. And the square root of 8, using a calculator, is 2.82. Okay, we can also look right here and see that square root of 8 is going to be super close to 3, which is what we got, 2.82. And square root of 10 is also super close to 3, which is what we got, 3.16. Okay. So now you're going to flip that page over again. And we're going to draw more side lengths. We're going to draw all the side lengths that can fit in a 5 dot by 5 dot. So they don't need to be a square now, they just need to fit. So remember the pattern that we did yesterday? And this is kind of unfortunate because the back is supposed to be more dots, but that's okay. So right now, it's every single side length that you can draw. So we have the flat ones. That's 1 and 2 and 3 and 4. And then we already know that a 1 by 1 is the square root of 2, because this is what we drew yesterday, and that a 1 by 2 is the square root of 5, and that a 1 by 3 is the square root of 10, and we could also fit a 1 by 4. So let's just draw that one and hold that for a moment. And then the 2 by 1 we actually have drawn, whoops, right here. That's a 2 by 1. And the 2 by 2 we drew yesterday, a 2 by 2, and that was the square root of 8. That's from yesterday. But we could also draw a 2 by 3. That's a 2 by 3. And we could also draw a 2 by 4. 2 spaces by 4 spaces. And then the 3 by 1 is right here. And the 3 by 2 is the same as a 2 by 3. So we can draw a 3 by 3. And we could draw a 3 by 4. And then we're thinking of our 4s. So a 4 by 1 is right here. A 4 by 2 is right here. A 4 by 3, I didn't label this one. And then we could have a 4 by 4. Okay, so we have 1, 2, 3, 4, 5, 6 ones that we actually don't know the side of. I'm just going to move this square root of 8 over here. So every unknown we have in its own box. Okay, so essentially what you need to do is you need to draw a square off of each of these 6 side lengths. So in order to draw a perfect square, you might need to add a row of dots. We're going to figure out the height, so this is 4, and the width, which is 1. So we're going to continue that pattern. So this is going to be a 4. Whoa, this is not the right color. So this is going to be a 4 by 1. And then you're going to put your dot and draw your line. So you see how this outer business is a 4 and a 1. Has a 4 and a 1. Then we're going to continue that pattern. So I would go 4. Okay, wrong color. Having some issues here. And then 1. And put a dot and draw the box. And then you can continue just to make sure you make it right back to home. Hold on here. 1, 2, 1, 2, 3, 4 by 1. So again, you see that this outer is a 4 and a 1. This outer is a 4 and a 1. And this outer is a 4 and a 1. Okay, so the outer box of this is a 5 by 5 because it's 4 and 1. So the outer box is 25. So our perfect square we're looking at, and we're going to find the area, and you would take the outer box and you would subtract each of these triangles. And we know the triangles are 4 by 1. So the area of a triangle is base times height divided by 2. So 4 times 1 divided by 2 would be the area of the triangle. So that would be 2. In each of these. So there are 4 2's, so that means there is 8. So you would take 8 away, and you would get 17. So this square's area is 17, which means the side length is the square root of 17. So every single side length that drops to give you a 4 by 1 triangle is the diagonal length of the square root of 17. Now, the square root of 17 is between 16 and 25. The square root of 16 is 8. The square root of 8 is 4. The square root of 25 is 5. So the square root of 17 should be 4 point something small, like 4.1, 4.2. If you put it in the calculator, you get 4.123. So 4.123. This is a side length, so it's just units. Square root of 17. Okay, 5 more to do this with. Now we have our 2 by 3. So I'm going to pick 2 colors. And I'm going to see how this is 3. And this is 2. And I'm going to continue that pattern. So because this is 2, we need to have a 3 going on. Because every single side is going to be a 2 and a 3. So because you've gone over 3, you're going to go down 2. Put a dot, draw your box. Continue the pattern. That's 2, so you need a 3, and then a 2. put a dot, draw your box. You can actually close your box, and then you can make sure that the grand finale ends at home base here. And you're going to notice that on the outside, every single one of these has a green and a red, and that's a 2 and a 3. So 2 plus 3. That means this big box is a 2 by 3. 2 plus 3. 2 and 3 by 2 and 3. That's a 5 by 5, which is 25. Each of these triangles is a 2 by 3. So 2 times 3 is 6. Divided by 2 is 3. So each of these triangles is 3. There's 4 triangles that you need to get rid of to have just the blue box's area. So those 4 triangles would be 3 plus 3 plus 3 plus 3, which is 12. So you need to take 12 away, and you're left with 13. This square area is 13, which means that every single side length is the square root of 13. Every 2 by 3 triangle is going to give you a hypotenuse, a diagonal length of the square root of 13. And it does need to be a right triangle. So see how this is a 2 by 3 right triangle? The longest side, the hypotenuse, the side across from the 90-degree angle, is the square root of the area. So the square root of 13, we're thinking of that lovely number. And we know that the square root of 9 is 3, and the square root of 16 is 4, and 3 is pretty close to in the middle, a little closer to 16, so I'm thinking like 3.6-ish. So I'm going to grab the calculator and type in the square root of 13, and it is 3.6055. So that is 3.606 square root of 13. 4 by 2. 4 by 2. Continue the pattern. 4 by 2. Put a dot. Draw your box. 4 by 2. Put a dot. Draw your box. Close your box. Make sure the 4 by 2 takes you right back to where you started. Then you know you did it right, which it does. This is wonderful. And so every outer box here is 4 and 2, that's 6, by 4 and 2. So this big box around the outside is a 6 by 6, which is 36. Every triangle is a 4 by 2, a 2 by 4. So the area of a triangle is base times height divided by 2. 4 times 2 is 8, divided by 2 is 4. So each of these are 4. We have 4 4s. That's 16. So we're going to take away 16, and you're left with 20. If the square's area is 20, that means the side lengths are all the square root of 20. You're now going to think about your perfect square roots. The square root of 16 is 4. The square root of 25 is 5. 20 falls right in between 16 and 25. It's probably going to be like 4.5-ish. So in the calculator, if you type in square root of 20, it's 4.472. Okay, go ahead and put this on pause and see if you can get the next 3 on your own and then come back and play. You can do them one at a time, or you can do all 3 and come back and see. So I just want you to have all of these side lengths and realize that anytime you have a 2 by 3, you have a diagonal length of the square root of 20. So hopefully you're done pausing with the answers to these 3. So this one is a 3 by 3. I'm still going to do it different colors. Okay, so 1, 2, I've got to add a row of dots. By 1, 2, 3. And then continuing. 1, 2, 3. by 1, 2, 3. And then making sure I get right back to the starter. Since that was red, I need to do my black 3 and then my red 3. Perfect. Okay, so the outer box here is 3 plus 3 by 3 plus 3, because these are all 3's. So this is a 6 by 6, which is 36. Same as this outer box that we just did. Now we have to take off the triangles. These triangles are 3 by 3's. 3 times 3 is 9, divided by 2 is 4.5. So you have 4 4.5. 2 4.5's is 9. So 4 4.5's is 18. So when you take off these triangles, you'll be left with the area of just this lovely green square. That is 18. So 18 is the square's area, so that means that every side length is the square root of 18. Going right back to our 16 being 4 and our 25 being 5, probably the square root of 18 is going to be like 4.2 or 4.3 because it's closer to 16 than 25. So in the calculator, if you do 4.18, it's 4.2426. So 4.243 units. Square root of 18. Isn't this fun? Back to feeling blessed. This time you have a 4 by 3. So wonderful that you can do this. Your brain is getting smarter every second here. Then we need our blue 4. We're going to have to go 2 dots down. Okay, so each outer box is 4 and 3 by 4 and 3. That's a 7 by 7. And 7 by 7 is 49. Each triangle is 4 by 3. So 4 times 3 is 12, and 12 divided by 2 is 6. So you have 4 6's because each triangle is 6. So that's 24. Which means you're left with 25. And what's kind of cool is the square root of 25 is a whole number, which is 5. So each of these are the square root of 25. And last but not least is your 4 by 4. Hopefully this isn't going to be too tricky. So this one we get to go off 2 spaces too. Grow our brain. We are so lucky this evening. So you're just continuing your 4 by 4 dotting. This time we get to go off by 3. This is so beautiful. Oh, 4 by 4. It's black, then green, then whoa, black, then green. Just pretend that connects better. And then whoa. 1, 2, 3, 4. Perfect. If I could just connect better, it'd be beautiful. Okay, we're going with that. Hopefully that looks squarish. But the numbers don't lie. So this outer box is 4 and 4. So this is an 8 by 8. And 8 times 8 is 64. Each triangle is a 4 by 4. So 4 times 4 is 16, divided by 2 is 8. And 4 eighths is 32. which means the square's area is 32. So you're thinking of your square roots. 25 is 5, and 36 is 6. So 32 is a little closer to 36. So take a wild guess what it'll be. I'm going to guess 5.6 or 5.7. And the real answer is 5.6568. So 5.657. So any 4x4 triangle will give you a diagonal length of the square root of 32. The square root of 32 is a better answer than the decimal. I just want to make sure that you know how to find square roots. So that is perfect. All right, we are going to stop right here because your next sheet is clear, and we will pick up here tomorrow. Have a lovely evening.